All right, everybody, welcome back to Stats. We're going to be looking at summarizing and describing data, getting into the very basics of descriptive statistics. So our objectives for this session is we're going to look at where the center is in the data set, and then we're going to determine also how much variability is in a data set. So let's get into the first one, looking at the center. These stats you're going to learn are called measures of central tendency. And they may be very familiar to you. These are ones that we often learn maybe in elementary school. It's where we're looking at where is the middle of a data set. A really good phrase to memorize to be able to remember what measures of central tendency are is measures of central tendency measure, okay, where the data tends to center around. Measures of central tendency. There you go. These measures are often called an average, because they usually result in one value that best represents an entire group of scores. Okay, so a good analogy for this is a teeter-totter, seesaw, whatever they are called these days, where the center is where the data is balancing on. So the idea here is that where is the center of our data set or the set of data that we're looking at? Where is the middle, right? What is it balancing on? Kind of like a seesaw here. So there are three measures of central tendency we're going to look at. We're going to look at the mean, the median, and the mode. Okay, and maybe these pictures can help you remember these concepts here. Now, the mean is the most common type of average. In fact, when most people refer to the average of something, they're usually referring to the mean in terms of the concept they're thinking of calculating or have calculated. Now, median and mode are an average. They're just not often used to. They're not often used. Average often is used to refer to them. Now, the way you calculate a mean is that you add up all the values that you have in your set of data, and then you divide the sum by the total number of values that you have. So here's the equation I want to introduce to you at this point here. So you have the mean, which is represented with a capital M here, equals the sum of x. So that funny E-looking symbol, that is the capital Greek letter called sigma, and it means in math to sum. So what it means here is sum all of x. X is the variable, so all of the numbers in your x, sum all those together. And then you're going to divide by n. N is the sample size. So here's some descriptions for you to remember that. So you calculate the mean by summing all the values of x, whatever x is, divided by how many values there are, meaning what is n? N is the number of numbers that you're working with. So let's try some practice with this. Say that I want to find the mean of the annual number of customers my 3 stores get at 3 different locations. So go ahead and calculate the mean. You can pause the video if you want to do this math, and then I'll show you the answer once you resume. So what you would do is you would add all 3 of these numbers up, and then you would divide the sum by 3, since we have 3 numbers, n equals 3. So what you should have gotten is 2,416. That's the average number of customers that I'm getting across my 3 stores in this scenario. Now, the median is simply the literal middle value when all the other values are arranged from highest to lowest, right? Or lowest to highest, it doesn't matter. Just as long as they're arranged in ascending or descending order, the mean is the middle one, the one that's right literally in the middle of all the numbers, okay? Now, definitively, the median is the number in the data set in which half of the numbers are above the median and half are below it, right? So 50% above, 50% below, whatever number has that characteristic is the median. Now, for odd number data sets where you have such as 5 numbers here that I've shown you in this table, you would take the middle value, right? So the median here obviously is going to be the GMC Denali here, 42,537, because that is the number right in the middle of 5, right? 2 below, 2 above, that is the one in the middle. Now, if you have an even number data set, you're going to have 2 numbers that are right in the middle. There's not going to be 1 in the middle because it's even, so there's going to be 2 in the middle. So if you have 4 prices, price number 2 and price number 3, they're the ones that are going to be in the middle. So what you do is you take the mean of the 2 middle numbers, and that's how you get your median for an even number data set. Pause the video and calculate the median, and then I'll reveal the answer. So the median for the second data set is 42,000. 447. That is the mean of the price for the Audi and the Nissan that you can see there. Now, before we talk about the mode, let's talk about the mean and the median for a second. Why use the median as a measure of central tendency? Like, why use it at all? Why not always use the mean? Well, the answer to this is that the median is not sensitive to extreme scores. These extreme scores are called outliers. Let me demonstrate what this means here. So let's say that I have this new list of 5 cars with their prices listed here in this table. Now, if you calculate the mean for all 5 of these cars, you get an average of 50,056. That looks to be like what the average cost of these 5 cars are. If you take the median, which is again the GMC Sierra Denali, you get 42,537. Now, that is very different from the mean. And the reason for that is because this Nissan down here is way higher than the rest of these prices. The rest of these prices are all kind of hovering around the 41, 42,000 range here, right? A little bit above, a little bit below that. The Nissan 84,000 is way above. This is an extreme score. And because the mean utilizes all the scores in the data set, it's going to have a mean that's higher than what the median what the middle actually is. The median is actually a little bit more accurate at this point. So what you want to do is look at the mean and the median. And if they're pretty close together, then that means that, okay, the middle really is what these two numbers are revealing. There's no outliers. Now, if the mean is very far from the median, there's a big gap between them, then that means that, okay, there's an extreme score or scores in the data set, and that's kind of pulling my average up or down depending on where the extreme score is. So this is why we want to consider both of these measures of central tendency. Now, the last one is called the mode, and this is simply the most frequently occurring piece of data. So when you think mode, think most. Now, usually the way this is represented is if you see a list of pieces of data, such as car colors, and I want to know how many times does that color appear in the data set, right? Out of all the cars that I have, I've got red, blue, black, and silver cars. How many are red, how many blue, how many black, how many silver? Now, the one that is the highest is the mode. So obviously that is going to be the silver car here because there are 55 cars greater than the rest of them that are silver. Now you can have multiple modes, right? What if black was also 55? Then black and silver would be the modes. So whenever you're asked to list the modes, you list the one that occurs the most. Now, if there are several kinds of pieces of data that occur the most, then you would list all of them because technically they're all the mode. Okay, so the ones that occur the most are the mode or modes. So that's measures of central tendency in a nutshell. Again, this might have been familiar to you if you remember from elementary school. So that's how we look for the middle of our data set. These are very common descriptive stats that are going to come up a lot throughout this course. Now, this next set of descriptive stats that are going to come up a lot are ones called measures of variability. And so let's talk about what variability is. Variability is how individual pieces of data or scores differ from one another. How spread out a set of scores are from each other. So take these two list of numbers, for example, right? The first one is 3, 4, 4, 5, 4. You can see that there's some differences between them. Now, the second one is just all fours. There doesn't seem to be any differences between them. Now, if I calculate the mean for both of these sets of numbers, they're both 4. So measures of central tendency can tell us where the middle is, but it can't tell us how different the pieces of data are from each other. So this is where we have to use different measures, different stats, descriptive stats. There are 3 measures for measuring variability, okay? Let's talk about the first one, which is called the range. Now, this is the most general measure of variability, and essentially what you do is you take the highest number in your data set and you subtract the lowest number in your data set from the highest one. So if you were to do this in these numbers that I have here below, you would take 98 minus 48, right? The average is 73, the range is 50, okay? Now, in general, a higher range score means more variability. So the higher the range, the more different the numbers are from each other. Now, here's a problem with the range. And the problem is that the range depends only on 2 numbers. It doesn't represent all the numbers of the data set. It only represents the highest and the lowest numbers. So there's situations where the range might be misleading. So take these 2 sets of numbers, for example. which data set obviously has more differences? It would obviously be the top one, because the bottom one, all but 2 of the numbers are all 5. So of course the top one has more differences. But would the range show us that? Would the range actually tell us the top one has more differences? Actually, it wouldn't. If you take the highest number in the top data set, which would be 72, and you take the lowest number, which would be 20, and you subtract them, you get a range of 52. Now here, you take the highest number, 99, minus 1 is 98. So the range that is higher would have more variability. So the second one appears to have more variability, but that's misleading because we know the top one is the one that actually has more differences. So the range is a measure of variability, but it's not one that is often used in statistics. You need to know it for this course, but moving forward after this section or after the first exam, you won't really mess with the range that much. I want to jump to the one that we're primarily going to be utilizing, which is called the standard deviation. Think of the standard deviation as the average amount of variability in a set of scores, right? What's one number that we can use to represent how much difference there is between our pieces of data, okay? So on average, how much do these scores deviate from the mean? That's a key thing about the standard deviation. We're looking at how much does each score deviate from the mean? How different is it from the mean? And then what we do is we kind of take all those differences and we kind of average them together to get one number. One number that tells us on average how much do the scores deviate from the mean. Now here's some symbols you need to know for this. In equations, you're often going to see standard deviation represented with a lowercase s. Outside of equations, you'll often see it represented with a capital SD. Make sure that you know both of these symbolic representations of standard deviation. Now, the way you interpret a standard deviation is that the smaller it is, the less variability. So it's similar to the range. The bigger the number, the more variability. The smaller the number, the less variability. Put it another way, a small SD means that the scores are deviating very little from the mean. The smaller SD indicates that the scores are closer to the mean than further from it. So this is kind of the basics of standard deviation. So how do we calculate a standard deviation? Well, you would use this equation here, and I'm going to break down the parts of this so that way you can understand it. Now keep in mind that SPSS is going to do this calculation for you. What you need to focus on for this class is comprehending what's happening here. You're not going to be tested on the precision of you calculating this equation. But you will be tested on your understanding of what this equation is doing, what's happening in the background of this statistical calculation, okay? Now let's break it down with the first part. We're going to focus on the middle part here, x minus x bar, okay? So let's give some description here. Now this part here is where we're calculating the differences or the deviation scores. How different is each score, each value of x from the mean, okay? Now x bar is the symbol for the mean inside of an equation. Outside of equation, it's capital M. Inside, it's x bar, okay? Now let's do an example to kind of walk through how this works. So here's a great way to calculate a standard deviation using this chart here, all right? So let's say we want to say how consistent was Joe at his test scores, right? How much variability did Joe have between his 4 test scores? So what you want to do is write down all 4 test scores ranging from least to greatest or greatest to least. Calculate the mean and put that in this second column here. Take the difference between each x score and the mean for this column. Then what you want to do is square this difference here. The reason we square is to get rid of the negative. It just makes things easier to work with. And then remember this symbol, lower capital sigma, means to sum. So we're going to sum all these numbers, all the squared deviation scores, we're going to sum together. Then you're going to take that number and put it on top of a fraction. And the bottom part is taking n minus 1. Remember, n is the number of numbers you have. So you would take the number of test scores we're working with here, minus 1, and you're going to divide the top part by the bottom part. And last but not least, you will square root. This is to get rid of that squaring, so that way we can put it back into regular numbers, so to speak, okay? Now I want you to go ahead and give this all a try. Pause the video, try to do these calculations, and then I'll walk through and see how close that you got to it. I really recommend you trying to do it by hand. This will really help the concepts sink in for you. So go ahead and try that now. Okay, now that you've got your calculations, let's reveal what we got here. So our average is 75. That's this Joe's average test score across the 4 tests. And we have 4 test scores, so we have n is equals 4, okay? And here are the numbers that you should have filled in, right? We list the numbers. A good way to do it is least to greatest. I forgot that I didn't do it on the slide, but that's just for the sake of organization. If you didn't, do it my way, do it your way, it all comes out right in the end. Whatever is the easiest for you to comprehend. So we're going to take each score. Let's start with 80. 80 minus 75 equals 5, right? That's how far Joe's first test is from his test average, about 5 test points. Now we square it, because again, like in the second one, minus 3, we want to get rid of that negative. So now we have our square differences. Then we're going to sum them all together down here, so we get a sum of 119. We're going to take 119 divided by 4 minus 1, which is 3. Now we get 39.66. Now that's squared units. That's squared numbers. It's hard to understand. Let's square root it so we can get back to normal numbers. So here we have our standard deviation score, 6.29, which indicates to us that Joe's test scores deviate from each other by an average of about 6.29 test points. That's really what a standard deviation is telling us here. So that's telling us how consistent Joe was on his test scores. Okay, let's do the same process with Bob. Pause the video and find the same numbers, do the same thing to get Bob's standard deviation. Now what we get with Bob is the following. You can pause the video to look over these numbers to make sure that you did the process right. And we get a standard deviation for Bob of 3.41. Okay, now here we can compare Joe and Bob together. Joe had a standard deviation of 6.29 test points, and Bob had a standard deviation of 3.41. Okay, now here's the question. Who was more consistent? This would be whoever had the least variability. Well, who has the least variability? Whoever has the lower standard deviation. Okay, and that in this case would be Bob. Bob has a standard deviation of 3.41. His test scores were deviating from each other by only 3.41 test points, where Joe's was deviating by 6.29 test points. So Joe had more variability in his test scores than Bob. So Bob, therefore, was more consistent in his test scores than Joe was, okay? And that is the standard deviation. This measurement is going to come up regularly throughout the course. So make sure that you've got this one down pat. Now, the last one you need to know, again, it's like the range. We're not going to use it much moving past this section, but it's one you still need to know that I'm going to test you on. The variance is the number that we square rooted to get the standard deviation. So if we look back at Joe's numbers, remember this number here, 39.66? That's the number, that's the variance, right? And we square rooted that to get standard deviation. So why do you need to know about the variance? Why don't we just use standard deviation? Some stats that we're going to get to later, such as the correlation, which you're going to learn at the very end of the course, uses variance, okay, in its calculation. So you've got to know what variance is, for one, because you just need to know it's a measure of variability, and two, because this measurement is going to be utilized in the calculations of stats you'll learn coming soon, okay? So make sure that you know what variance is. We don't use it because it's hard to interpret, which is why SD is preferred, okay? So that's the main reason. Now, the last thing I want to wrap up with is setting us up for our next section. The standard deviation is a score. Now, what do I mean by this? Standard deviation is a single score which represents how much individual scores vary from the mean. So to give an example, let's take Bob, right? One standard deviation for Bob was equal to 3.41 test points. Now, how many test points is one standard deviation from Bob's mean? 3.41. We got that. Now, how many are two standard deviations? Well, you would take 3.41 plus 3.41, and we get 6.82. So 6.82 test points is about two standard deviations away from the mean for Bob, okay? Another analogy to help this make sense is take 1 foot. How many inches are in 1 foot? 12, right? How many inches are in 2 feet? 24, right? 12 plus 12. That's the same concept here with one standard deviation. Now, this is going to be very important for the next section, talking about normal distributions. And so you want to make sure that kind of look over this, get the information down in your mind, and it'll sink in deeper when you get to the next lecture.